Buffer overflow are one of the oldest and most commonly exploitable software vulnerabilities. They have existed for as long as there have been computer programs. They are also one of the most common software design and implementation errors. In fact, in some programming languages, it is very easy to make mistakes and write the software and firmware that cause illegal access to program memory, and which is basically what buffer overflow is. Fortunately, potential buffer overflow conditions are usually easy to find and fix if you have the program source code. So what does a buffer overflow looks like? Well, because buffer overflow conditions happens inside the computer, they are not easy to actually see the effects of an overflow. May be noticeable by a changing your computer's behavior, but you cannot see the overflow itself. The drinking glass overflowing with water is not a very accurate analogy. Either the closest thing I can think of in real life is when you are filling out a paper form and that contains tiny little boxes for writing your information in, and that if you have a lots of information to write, such as a very long file name, and then it's really easy to run out of room and write past and end the box into the next box, overflowing information to where it shouldn't be as it were. If you think of the boxes on the form is buffer and what you write in them is data, and then you can visualize what's happening in a program's memory when buffer overflow condition occurs. If you see into the memory used by running computer program, you would see many sequential memory elements that are used to store programming data. We usually use a 1 or 2 dimensional grid to represent how these elements are organized from this memory. The program creates buffers for storing the data is used by the program. So if you could see the actual data stored in a program's memory, then there are many tools that will allow you to do this. You would see a world of nonsensical gibberish punctual, which is punctuated with numbers and characters of which may look familiar to you. Let's take a look at what a buffer overflow looks like from the buffer's perspective. Here we can see a buffer allocated with 8 memory elements for storing 8 bytes of data. The elements are numbered 0 through 7 because while computer starts counting at 0, so most programming languages do as well. The memory elements following the buffer might belong to another buffer and some other program, or maybe there are some unclaimed memory and not in use at that moment. So all we know is those adjacent elements that we are not part of our 8 element buffers and or outside of our buffer memory bounds. If we write the character string password into the buffer, we can see all of the data written into the buffer state within the buffer memory space. However, if we were to write a longer string in the same size buffer, the additional data would overwrite several of the memory elements which is adjacent to the buffer. This is exactly what a buffer overflow condition is. Another reason why an analogy of a buffer overflowing with the data is like drinking glass filling and overflowing with water is not entirely accurate. It is because of gravity. A glass must fill with water from the bottom up, but in buffers, we in memory can have the data written to them starting at any element. You can overflow a buffer by writing to only a few of the element and not filling up the buffer at all. So when you see a buffer overflow occurs, not because the buffer is full but because the written, which is writing of the day to the buffer, has overrun the memory boundaries of the buffer. This is why buffer overrun is I guess you'd say the more accurate description for this condition. But in terms of buffer overflow, that has stuck in modern cybersecurity as we speak. Common buffer overflow and overruns exceed the memory boundary at the end of the buffer. A related condition exceeds the memory boundaries at the beginning of the buffer. This is known as the buffer underflow or the buffer underrun. It may seem strange to fill a buffer with the data starting from end and proceeding backward to the beginning, or filling the bottom of the buffer or to the top, depending on your view. But in some software design, there are reasons to do this, and we just overflows and overruns. If you aren't careful when you are writing the buffer, then many elements you are willing to write, then you can easily write past the beginning of the buffer, causing a underflow or underrun condition. One last point for me to harp in is that the buffers are always writable and they overflowed by writing data to them. However, it is also possible to exceed memory batteries while reading from the buffer. This is not an overflow condition because no data is being written to memory location where it shouldn't be attempting to read past, but at the end of the buffer or prior to the beginning of a buffer, it still can describe as overrun or underrun conditions respectively. So be sure to note the detailed description of any exploit level as an overrun or underrun to check if it's writing and reading data in its operation. You might be surprised at the data you can find by just attempting to read places and program memory that are outside of but close to the boundaries of a buffer. So buffer aren't the only things that can overflow. There are another condition called integer overflow that can be also exploited for various purposes. However, but for overflows and integer overflow are not the same thing, and you should understand why. Integer are what we human typically call number values that are stored in fixed size areas. Program memory referred to as a variable because the value can be changed. As integer are limited to a specific range of values based on the integer variables such as negative 32768 to 32767, which is sign 16 number, and 0 to 25 to 55 for unsigned 8-bit integer. If we perform an arithmetic operation that exceeds the upper or lower size of the integer and attempt to store the result of the integer variable, which is very small, the value will roll over the values on the other and the end of the integer range. The condition is referred to as an integer overflow, although integer roll Over might be more accurate description. For example, adding 1 cause the larger integer value to roll over or overflow to its lowest value like cards. Odometer flipping over the 9 to all 9 to all zeros going through the opposite direction, subtracting 1 for the lowest value result in the highest integer value. Highest integer value of the programming who wrote the code to anticipate the possible of integer overflow and underflow condition and handle them. According the two major problems that can occur with unhandled integer overflow are unexpected results from data calculation and unintended changes and program logic flow. This condition can cause a program to return bad data and perform actions that are not intended by the program's designer. Many significant operation and security issues have resulted from integer overflow and underflow. One type of overflow can lead to another if an integer overflow condition results in the miscalculation of a buffer size or a buffer overflow condition unexpectedly then changes and its value of an integer variable. As I previously mentioned that when a buffer overflow occurs inside a running program, what are more things could happen as a result in the real world that is human live in a result of an overflow that can be trivial and inconvenience purposeful and have a very dire consequences. The same is pretty much true for overflow in the virtual world that computer program run in. Let's take a look of the few consequences of a buffer overflow. Local denial of service. So denial of service is a term that used to describe a condition in which program systems are networks are prevented from providing information transfer and processing services at an acceptable level of performance. Those conditions can be caused by various of ways, but it is always intentional and often malicious. So the occurrence of buffer overflow can cause DOS and DOS mouse condition for this reason. The exploitation of buffer overflow vulnerability is often an attack used in denial of service attack. Rendering a system unable to adequately provide services can be done locally or remotely. So performing a local DOS attack of the system that the attacker has physically access so that he can be as simple as just unplugging the computer's power code or network level. If the attacker can log into the system from the console with administrator privilege, key services can be stopped or the entire system shut down. And when an attacker has a physical access to a system, it usually game over, like remote denial services, which attacker has access a system over a network from the network, and the attacker can attempt to degrade the performance of a remote system by sending a great amount of network traffic to overwhelm the communication ports or by making information by processing request. The exhaust system resources or exploiting vulnerabilities that cause services running on the computer to crash. All of the denial of service attacker can use buffer or overflow vulnerability exploit to achieve their goals. A key understanding of denial service attacks as realizing that they are caused properly in maliciously. However, there are also non-malicious reasons to cause a denial service. So, if you discover that someone was remotely accessing your computer without authorization, your quickest response would be to just unplug the computer from the network. Cause again, denial service to the intruder, the action would not be malicious because you are protecting your own asset, but it's a defensive reaction, not just an attack. But what about the accidental denial of service conditions such as mistakenly leaving a file or a database to a connect network which communicate device unexpectedly falling, or just a server losing power because somebody accidentally pulled its power cord? Because these situations are accidental or natural rather than intentional. They are typically referred to as failure or outages because the root causes of the problem was not just for purposeful attack of denial of service. Buffers are used to hold data that is inputted, processed, and outputted by the program's code, but for overflow vulnerabilities are capable of changing data in program in a way that program designer did not intend. If the changes result in a corrupt data, this may alter how the program operates. If the corrupt data is invalid and because of the change in data outside the program will occur when carefully controlled. Fault information may be propagated by a overflow condition into other system and databases. Programs also use the data to make logical decisions. Each time you use a computer programs, you are inputting information to tell the program what to do for you, and this is the data input for the purpose of controlling the program logical operation. If you could input data that cause the program to operate in the program that designer did not want, you would have discovered a bug. Sometimes a buffer overflow bug can be used to specifically influence how a program behaves. The new behavior may be benefit to attacker looking for a way to defeat the security of the system. The next time you log in to an application or page, imagine what would happen if someone inputting your correct password you copied and pasted from thousand different random character into a password field and hit the enter key. What would you expect to happen? You would see a message like incorrect or username password fault, which would be a proper response. You might see some cryptic error messages, which could be an indication that you input password or username was not handled properly and a security vulnerability made clear. But would you be surprised if you have successfully authenticated and granted access? Overflowing the buffer of an input field with unexpected data can cause a failure of the program. We select the correct course of action. Like if you put the right user and password, then it's easier for you to see that log in the successfully and program logic to select the correct course of action. The term commands and control, abbreviated CNC and C2, is a military term that basically means to exercise a command authority to direct forces in accomplishing the goals of a mission. The cybersecurity world has adopted the phrase to describe the taking of the command of one or more computer system by an attacker and using the system for malicious purposes. Command and control is a phrase commonly used in a world of malware and botnet because of the need of attacker to provide direction and receive information from the malware, and command of exploit to install and run command and control malware. And finally, the command and control malware using buffer overflow exploit is a popular way to do that. So how do buffer from overflowing? How do we keep buffer from overflowing? By just safeguard and countermeasures. Safeguards encounters measures to add to our overall risk, mitigating strategy. The logs will not be necessarily prevent every intrusion attempt, but they are part of the proactive mitigation strategy. And for the countermeasures, are controls that come into play after a threat has occurred. If somebody picks the lock on your door and enter your premises, an alarm system can react to the threat by silently informing the local polices that are turning on the lights and siren in your home to scare the intruder away. The alarm system will not have prevented the intrusion, but it chooses to have mitigated the amount of damages that could have resulted from a active intrusion threat. Our safeguards encounter measures against buffer overflow and technical administrative, not physical, and are performed by programmers, system administration and information security professional. Let's have a look. What we can do to prevent buffer overflow condition from occurring. Like the best way to do is to not creating a problem code to buffer. So the programmer do is to write safer codes that used to, like, for the benefits of programmer to fix the code and to have the code tested for the system administrator and user to find valuable programs for patch vulnerable programs and remove vulnerable programs for system administrators who don't disable and forget programs, and for users to learn about the software security issues and it uses, and for that reason it do not use unknown or untested software and do not trust unverified software distributors.